Greetings again. In my previous video I did an introduction to integration. Excuse me. So in this one I'm going to go a little bit deeper. I'm going to talk about indefinite integration and definite integration and the differences, and we'll do some worked examples, and then you're going to have a go at some, and then I'll work through the answers for you. Okay, so let's do a quick recap, just looking at the basics. So looking at the first one, so what we've got here is I'm going to define it as this way. I'm going to say that if y equals the integration of 4x3, we have to define what we're integrating in relating to. So we're doing it in relation to x, so x is a variable. We have to say, or we wouldn't know. So if we just had a number, for example, we wouldn't know if it was x or t or theta or anything. So we have to say what it is. Okay, so y will equal, so if we integrate this, we've got 4x to the 4, and then we divide by the power, the new power. So what we're doing is we're adding 1 to the power. Remember, we're working backwards to what we would do if we were doing differentiation. So in differentiation, we took 1 away from the power, which was the last thing we did. This time, the first thing we do is add 1 to the power, and then when we did differentiation, the first thing we did was multiply by the power. This time, we're going to do it the opposite function in the opposite order. So it's going to be a divide by 4. And then we have, don't forget your C to remind you about anything that's any constants that have been missed out. And if I simplify that, we will get x to the 4 plus C. Now, if you're not clear about your result, simple way to test it is just to go backwards, differentiate it, and see if you get back to where you started. So if I differentiate this, the 4 would come to the front, take 1 from the power, 4x to the 3. The C doesn't have an x, so it's a constant, so that disappears. That becomes 0. So that's worked. And the second one, we can't integrate it in this way, so we've got to change it into this manner using our laws of indices. We've got to bring it to the top, and it becomes a -3. So it's the inverse of x to the 3 is the same as x to the -3, and we need to define what we're integrating in relation to. Okay, so now we can integrate this. So we've got y equals, so add 1 to our -3, it's going to give us -2. Divide by that answer, -2. Add our C for constant. Then we can do a bit of simplifying. There's not much we can do here really. We just bring the minus sign to the top. That's more for convention reasons. It doesn't change anything. And that's the final answer of that with our C of constant. Okay, the next one, if you remember this one from last time, we've got to watch this one. It's a tricky one. So let's just try it the wrong way. So y equals the integration. So if I bring my x up to the top using laws of indices and get x to the -1 in relation to x. Okay, now let's see if I try solving this, I will get x -1 plus 1 is going to give me 0, and then I'm divided by 0. So it can't be done. This is an unusual situation. This one has to be done with, the answer to this one is simply log of x. Natural logs, remember, plus C. So if in doubt, if you remember, the differentiation of log of x gives you 1 over x. So that's what we've basically done. Okay, next one. So this one we've got y equals 4 sine 2x dx. Don't ask me why I put the bracket there. Okay, so this one, remember what I said about these, do it the stuff you know first, that's easy. Well, we notice the other function, shall we call it, the cosine. We know everything in the bracket stays the same, never changes, so do that bit. Put the 4 down. Oops, floated up a bit. Right, let's start thinking about the differences. Okay, a sign, to get a plus cos, it should be a minus sign. So we should have a minus sign here. Think of it the other way around. If we differentiated cosine, then we get a minus sign as the answer. So we must have started with a minus in the first place. Okay, what happens to this 2? Normally the 2 would come out to the front and multiply into the front, but because we're doing the opposites, it's a divide. And don't forget you see a constant, and if we simplify that, we've got minus 2 cosine 2x plus c. Okay, one more and then we'll get on with some more tricky ones. Okay, y equals 2e to x. Now remember when we differentiated these, the 2 would come out and come to the front as a multiplier. Forget my symbols here. So what's the opposite to a multiply? Simply enough, a divide. So we're going to have 2e 2x. The thing in the function, you could argue that this should be written in brackets, and you could say the thing in the bracket stays the same. Anyway, the 2 comes down this time as a divide. Plus c. Simplify that, we get, so the 2's will cancel, so we get e2x. And again, you can test your result by working backwards, differentiating it, and see if you get back where you started, which of course we would, because the 2 would come to the front and the c would cancel out to a 0. Not cancel out so much, but it would go as a 0. Okay. So if we take a look at this one, so this one actually gives us the answer. Y equals the integration of 4x dx, then y will equal 2x squared plus c. Now we call this an indefinite integration. It's where we haven't got limits on our integration because the answer is indefinite. Okay, because we don't know what c is. Now there's certain circumstances where we can actually work out what c is, and this is when we've been given what we call boundary conditions. So we've been given some here. We say that when y equals 2 when x equals 4, and from that we can find out what c is. So I've got a solution here. So if I put my numbers in, so we've got 2 equals, so it's 2 times 4 squared plus c. So if I do the maths on that, 4 squared is 16, so it's 32 after you've multiplied it by 2. So c. So that tells us, if I take this 32 through to the other side, that will tell me that's therefore, this is the shorthand symbol for therefore, if you don't know, therefore c equals, minus 30. Okay, right, if I put that back into my formula, my original formula, so we've got y equals 2x squared, and this is minus, so we'd start every plus up here because that's the standard, but that plus actually could be a negative. Okay, so we've got minus 30. And that's the solution. That's now we can put any value of x in and we'll find out a value for y. If you just want to test this, if you put 4 in, x is 4, we'll get squared is 16 times 2 is 32, minus 30 we'll get y is 2. So it just proves it. Okay, let's have a look at this one. So definite integration is where we have limits. So we took my example from previous example, and I've now put limits in, say from 0 to 3. So what this is actually doing, this is giving you the the shape under the curve. Oops, that's a terrible sketch. So we've got some curve, and we're finding from here 0 to say here, call 3, and we're looking for that area under there. And that could be the answer to something like the amount of energy that's been done. So this could be a formula to do with power, and if we find the area, that will tell us the amount of energy that's been used. So let me do an example. So if I integrate this, I will have y equals, so 4x, so raise the x by 1, we've got 4x2, divide by the 2, plus c, but we've got limits, so we put it in square brackets. Sometimes you'll see it written with just a solid line down here, and then the limits will be put on this against a solid line like this. I have seen it done that way, but usually in the UK and I think in Europe they tend to do it in square brackets and put the lower limit at the bottom and the upper limit at the top. So this tells us what part of the area we're looking from, the difference from here to here. So basically it's 3 minus 0. Okay. Now I can obviously tidy this up a little bit, so let's do that. Y equals, so the 2 will cancel, so we'll end up with 2x squared plus c. Now when we do definite integration, we don't need to put the c of constant in, for reasons that you'll see in a moment, but I'm just putting it in to prove the point really, and see what happens. So if I solve this, what we do in definite integration is we substitute the value, so we put the upper limit in first into every place as an x, which we've only got 1 in our example. So we've got this, we've got 2 times 3, because we've substituted in the 3, squared, plus c, minus, and then the second time we're going to substitute in 0, which in this case will be nice because it will simplify a lot. So 2 times 0 squared plus c. Now if you look at this, obviously 2 times 0 squared, this squared, 0 squared obviously is 0, 0 times 0 is 0, anything times 0 is 0, so this is going to go. Now if I subtract, I've got c minus plus c, so it's going to become minus, so it's going to be, so they're going to go, and that's why you do not need to put the c in. You can see of constant when you've got limits, as we have here. Okay, and then so we've got 3 squared, so that's 9 times 2, so it's 18. So 18 units depending what we're looking for, which actually could be square centimetres, square metres. Okay, so that's straightforward. Let's have a look at a more practical example. So we've got the power consumed in an electric circuit, which can be defined as P equals 4t plus 8. So find the energy applied from 2 seconds to 4 seconds by means of integration in the function in relation to t, where t is time. So let's have a look. So we've got here, so P equals 4t plus 8, so we're looking for energy. So the energy, use the symbol E, equals the integration of 4t plus 8, and we have to define what we're integrating in relation to, which is t for time. Okay, so if we solve this, so 4t becomes 4t to the power 2 divided by 2 plus, sorry, I forgot my limits here, didn't I? 2 to 4. Okay, so we've got our limits from 2 seconds to 4 seconds. Now 8. Now if you've said straight out right 8, that's a constant, it disappears. Well, I'll have to applaud you for trying, but it's wrong, because that's differentiation. We're going backwards, remember. So really you've got to think in terms of what would give you 8 when you differentiated it. and the answer would be 8t. Another way of looking at it is that we've got 8 to the t of 0, because t to the 0 is 1, of course. Raise this to 1, you get t to the 1, so there's your t, divide by 1, which obviously leaves it the same, so that leaves you with your 8t. Because we're doing definite integration, we don't need to put the c of constant in, because it'll just cancel out, and our limits are from 2 to 4. Okay, so our e equals, so this will cancel down to 2, so 2 times, so we're substituting 4, so 4 squared is 16, so that's obviously going to be 32, plus 8 times 4, 32 again, minus, so this time we're substituting in 2, so it's going to be 2 squared is 4 times 2 is 8, plus 8 times 2 is 16, oops, 16, so we've got there 24 minus 34, here we've got 64. Okay, so 64 minus 24 is 40. So the energy is going to be 40, and that's joules, of course, 40 joules. Okay. So on the next one, take a look at these two. So maths is not a spectator sport, so these are two for you to have a go at. So what I want you to do is take a look at them, pause the video at this stage, and then I will begin in a few seconds and work through and give you an answer to them. Okay, so welcome back. Let's have a look at the first one. So find an expression if y equals 3x squared. Find the value of c if y equals 0 when x equals 2. So firstly we're going to solve it. I'll do this down here. So y equals, so the integration of 3x to the 3, well that's quite straightforward. It's going to become 3x to the power of the 3, adding 1 to the 2 makes it 3, divide by 3 plus c. And if I simplify that a little bit, we'll just get x to the 3 plus c. So if I substitute in my values for y and x, I've got 0 equals 0 for substituting into y equals 2. So 2 to the power of 3 is 8 plus c. So the only value of c that would make 8 become 0 when it's added to 8 would have to be minus. So therefore c must equal minus 8, because 8 minus 8 is 0. Okay, so that's straightforward. Let's just, in fact, let me just erase that. Okay, the second one. So we've got, find the energy used from 0 to 4 seconds if p equals 6t plus 3. So let's have a look. So we're using E again. E equals the integration of 6t plus 3 in dt. So E will equal, so t is to the power of the 1, so add 1 to it becomes 2, so we've got 6t to the 2, divide by 2, forgot my limits again, 0 to 4, then we've got plus, so if you remember, if you've got a simple constant it gains the variable t, so that's 3t, put it in square brackets, Put the limits on, lower limit to upper limit, simplify. So 6 divided by 2 gives us 3. Okay, 0 to 4. So therefore, E will equal, substituting in my values, 4 into T, so that's going to be 4 squared 16, 3 16s is, what will it be, 48. I'm good at this maths. 48. Plus 3 times 4 is 12. Minus, so this one, and I've gone with the 0, so the nice easy one. So this is going to become 0 basically, because 0 squared is 0. So 0 plus 0, because 3 times 0 is 0. So that's a nice easy one. So we've got 48 and 12, which gives us 60. Okay, so E equals 60 joules.